Hello dear students, welcome on this video lecture. This is the lecture in the series of errors and measurements. Prior to this, there have been couple of lectures on this particular chapter, and in this chapter we will be focusing up on the errors in measurements. That means whenever we do the measurements, then errors come in that measurements, what they are, what are their types, and how we find these errors in that measurements. Okay, so let's begin with the definition of error. So how we define the error in any measurements. So whenever we do any measurement, we will be measuring some physical quantity, and that physical quantity will have some true value. So error is defined as, or we can say it is the difference. It is the difference between true value of a physical quantity and measured value of that physical quantity. Measured value of a physical quantity. Physical quantity. So that's how we can define the error. Error is the difference between true value and measured value of a physical quantity. This we can also write as errors are equal to, or error is equal to true value of any physical quantity minus measured value. Now measured value can be found out after doing the experiment, and true value is something we are interested in, and then the difference of the two is the error. So suppose we are interested in finding out the true value. So from here we can have this expression that true value is going to be equal to, let me write over here, true value of any physical quantity is going to be equal to measured value plus error. So if we know the measured value, if we know the error, then we can find out what is going to be the true value using this expression. So point is, the true value, if we want to find the true value in any experiment, then we need to find the measured value, and we need to know what the error is in that measurement, and putting these two together we can find what the true value of that physical quantity is going to be. Now in order to make your measured value close to true value, we would like to have this error as minimum as possible. So purpose is to minimize the error in the measurement. This error can be positive as well as can be negative. So we would like to minimize the error in the experiment so that our measured value becomes close to the true value of the physical quantity we are measuring. So we need to know what type of errors are and how we can minimize those errors. So here the next point says types of error. So errors can be categorized basically three types, which have been shown by this flow chart. So these errors are, one category is systematic errors, and another is known as random error. The second is random error, and the third is gross error. So we can say these are the three types. Let's try to learn what they mean. Systematic errors are those errors which can be identified, or the cause of these errors are identified or known. So they have known cause. So if I want to write in short, it can be written as, these types of errors have known cause. So since we know the cause, of the error, then we can work on that cause, and then we can improve that measurement or remove that error. For example, if you want to know the example, let's say we are measuring length of some object, and in previous videos we have talked about vernier calipers and screw gauges. Let's say we are using vernier calipers and we are measuring some length. So when we are using vernier calipers to measure a length, we need to know how our instrument, that's vernier calipers, is. Does this instrument carry any inbuilt or systematic error? So the zero error, let's say if we talk about the zero error in that instrument, so this zero error is a systematic error. That means systematic errors are because of some fault in the instrument, and the cause of which is known to us. And if we want to improve this measurement or improve our result or compensate for the errors, then we can compensate the zero error in the measurement. In the previous video we have talked about, we measure the zero error, and in final expression we use it to find out our result very close to the true value. So these systematic errors are removable because their causes are known. An example for this type of error is a zero error in instruments, right? So they can be removed because their causes are known to us. Second type of error is a random error. These errors are such that we are not able to find out what the cause of the error is. So cause is unknown. When the cause of the error is unknown, cause of error is unknown. Since the cause is unknown, it becomes for us difficult to remove this kind of errors. Yes, but we would like to minimize those errors. In order to minimize, what we do, we take several number of observations. So large number of observations helps us to remove this kind of error. Large number of observations or measurement. So large number of observations help in reducing the error. For example, what the random error is, we can think by example. Let's say a person is doing an experiment and finding out the value of some physical quantity, and if the person repeats the same experiment, he or she finds different results. So if the same person doing the same experiment repeatedly, every time the result is coming different. That means the cause of the error that is involved is not known. And if we want to reduce this kind of error, what we need to do, we need to take large number of observations. That means we need to repeat the experiment large number of times, and then finally we will take the average value. So we will take the average value of all the measurements. That arithmetic average value will be very close to the true value. That means that will have a very small or minimum amount of error. So how we can minimize the error in random errors? You need to say that take the large number of observations and then take the mean value of all the observations. That mean value of all the observations is going to be close to the true value. That means that value will have a minimum error involved. If you are taking one observation and claiming that is your answer, so that's going to be having a big amount or large amount of error. And error can be minimized by taking a large number of observations. So we will talk about random error in more detail in this particular video. So there is a difference between systematic error and random error. Systematic error is because of some region that are known to us. We can work on that region, remove that error, and we can get a precise measurement, or we can get rid of this kind of systematic error. But random errors are difficult to remove. For that purpose, we take large number of observation to minimize the error. And there is a third type of error, that is because of some faulty observations, that means because of carelessness. So if we are causing any error because of non-sincereness or non-focused or carelessness, then this kind of error arrives. So we can simply write it is because of carelessness. So if some person is doing an experiment and that person is not sincere about taking the readings, doing right calculations, so because of that, one can also introduce errors in the final result. If the errors are coming because of personal faultiness or not putting the proper attention, that kind of error is known as gross error. How we can remove or minimize this kind of error? Simple. For this type of error to remove, one need to be very careful when taking the observations. One need to be very focused, attentive to write down the observed values and make sure that the experiment is properly designed and there is no externally coming error because of the observer. Okay, so this third is because of focus or carefulness. uh, by using focus and carefulness we can minimize this. Second type we can minimize by taking large number of observations. First we can minimize by finding out the cause and then appropriately making the corrections. Okay, so first we have talked about like zero error. We can have a correction for zero error, that's called zero correction. Gross error can be removed by just focus improvement, and the random error is something we are going to deal with. In this we will be taking large number of observations. Out of those observations we will be finding the average value, and then still will be there will be some error, but that error is going to be minimum in that experiment. Okay, so from this slide we have understood what the definition of error is. It's a difference between the true and measured value, and types of error: systematic, the cause of them is known to us, they are removable; random, causes are unknown; large number of observations helps us to minimize the error; gross, which is because of non-attentiveness. So attentiveness is going to help in reducing the gross errors. In the next video we will talk more about absolute errors, errors in measurements which are coming because of random nature. Okay, so let's go ahead. So now let's talk about absolute error and mean absolute error. Better would be if we start with some experiment. So let's say there's experiment taking place. So and let's say a physical quantity. So let me write, let a physical quantity x is being measured. X is being measured in an experiment. So in an experiment we are measuring a physical quantity called x, and we are repeating that experiment, let's say n times, and these n times the observations are as follows. So observations for these n repeating experiments are for this value quantity x. Let's say in the first experiment the value measured is x1, in the second experiment x2, in third it came out to be x3, and so on. And in nth repetition the value of same physical quantity came out to be xn. So x1 is the value of x or that physical quantity in the first observation, x2 in the second observation, x3 in the third observation, xn in the nth observations. So we are taking n number of observations to talk about the random error that are going to be there. So these x1, x2, x3, these are the absolute values of measurement in different observations. Now if we are talking about what the mean value of this quantity is going to be, so we can talk about mean value. So we can write it as x mean. or simply xm. Xm is representing the mean value of observations. So we know, we take this arithmetic mean, that means we will be adding all the numbers or all the observations and dividing by the number of observations that we have taken, divided by n. So if we sum all the observations and divide by the number of observations, then we call it as a mean value of that physical quantity. Now this mean value is going to be more appropriate as compared to these individual observations. That means this is going to be very close to the true value. Since the exact value of any physical quantity is not known to us, so we will be considering this mean value as the true value. So this will be behaving for or working for us as a true value or correct value. We can also call it as a correct value. So if somebody asking what is the correct value of a physical quantity in a measurement, then you go for the mean value, find the mean value and say that mean value is the correct value or true value. Then what is the absolute error? No, if this is the mean value or true value that we are finding, in the first experiment the value was x1. Now this xm, or that means mean value of this experiment and the first observation in the experiment may be different. So whatever the difference between these two quantities is, that is the absolute error in the first observation. Similarly, in second observation we can find the absolute error by by making a difference of these two quantities. So we can say, now we can define what the absolute error is going to be. So this absolute error is, let me write over here, absolute error is the magnitude of difference between mean value, which we can call as a true value, and measured value. This is how we define the absolute error. Absolute error is the magnitude of difference between the this mean value or true value or correct value and the measured value. Okay, so if we are talking about what is the absolute error is in the first observation, so errors we write by delta. So we will writing delta x1. If we are writing delta x1, that means it is talking about the error in first observation. So this will be read as a absolute error in first observation. So this is going to be mod of xm minus x1. So we are going to write this absolute error as the magnitude. For magnitude we put this modulus, and that's difference between the mean value and the observed value. The observed value is x1, mean value is xm. We are taking the mod so that it becomes magnitude, and this is going to be equal to delta x1. This delta x1 will be known as absolute error in the first observation. Similarly, in case we need to find out absolute error in the second observation, can you think of what this is going to be? Yes, you can think of, it's going to be again modulus of difference of mean value and the observed value in the second observation. Can we find similarly the absolute error in the third observation, fourth observation, fifth observation? If we are coming to the last observation, so we will be writing as delta xn. Delta xn will be modulus of mean value minus nth observed value. Point is, for each and every observation we can find out the absolute error. That means absolute error is the magnitude of difference between the mean value, which we call as a true value, and the measured value. Measured value can also be known as observed value. Making sense or not? It should make sense. Now if it is making sense, then we can go for the next term, which is involved as a mean absolute error. Now these are absolute error. Delta x1, delta x2, delta x3 and delta xn, these are the absolute error. And if we are interested in mean absolute error, that means we need to find the mean of these errors. So let's write mean absolute error, mean absolute error. From name you can think of is going to be mean of the absolute errors. So if we are writing as delta xm, its delta is going to be error, known as error of x as a mean. So that means its a mean absolute error is going to be equal to delta x1 plus delta x2 plus delta x3 and so on up to delta xn divided by n, because we are having n number of these absolute errors. So if we know these absolute errors, we can always find out the mean absolute error. This was delta x2, so let me write it properly. Delta x2. I hope you are getting it. So if we have found out the absolute errors, we can find out the mean of these absolute error, that's known as mean absolute error. So sometimes in examination it is being asked find the mean absolute error. So what we are going to do, we are going to find out first of all we are going to find out the mean value. How to get this mean value? There is a formula, mean value of this observations. These observations will be given to you. There will be a question stating like there is a physical quantity, that physical quantity is being observed by in an experiment, and the observed values are x1, x2, x3, x4, whatever the number that are going to given to you. You will use those observations. First thing, you are going to find the mean value. In mean value you sum all the numbers, then divide by the total number of observations, you will find the mean value. The next point will be to go for the absolute error for each and every observations. So for x1 observation, this is going to be the absolute error. For x2 observation, this is going to be the absolute error. What is the absolute error? It's a difference between the mean value and the measured value. This is the mean value and this is the measured or observed value. Just make the difference. The difference is going to be this absolute error. Now mind it, these absolute errors are magnitude, that means they are the positive, so we simply going to write the positive value. That's why we are putting the modulus of it. Once we are able to find these absolute errors in each experiment or in each observation, then we can find out the mean of these errors that we have found out. So mean absolute error is going to be mean of, that is arithmetic mean of all the absolute errors. So delta x1 plus delta x2 and all that thing, we are going to sum them up by and divide by n. You know, in mathematical operation notation, we can also write it as a summation of delta xi divided by n. In short, this I is going to run from 1 to n, so it has to be running from 1 to n, and that's going to be a different way of putting the notation or mathematical notation for the same quantity, right? So this is an important aspect of finding the absolute error, mean absolute error, and the mean value. I hope it's making sense. And if you are going to make a notes and revise, then you'll find we are just using the common sense, the mean value, error, which is absolute error, that has a particular definition, then taking the mean of these absolute errors. Now we can move ahead and talk about some other aspect of it. Okay, before proceeding further, it will be better if we take this example. This is a solved example, and let's try to use the concept that we have learned so far in this video lecture. So it is talking about basically question related to these mean value, mean absolute error, relative error, and percentage error. We will talk about relative error and percent error shortly, but yes, we can use the concept for mean value and mean absolute error. So it says repeated experiments of a certain physical quantity in an experiment gives the following values. These are the values. That means these are the observations. How many observations are there? So that's a one observation value, second, third, fourth, fifth, sixth, seventh, and eighth. So 8 observation has been taken for a particular quantity, and we are expected to find out or calculate the mean value. So mean value of that quantity which we are taking the observations of. So, and the next thing that we need to find about is the mean absolute error that we have just finished. What is the mean absolute error? We know that. And then we will be finding the relative error and percentage error. Finding the relative error and percentage error is quite simple once we are able to find these first two things. So let's see how the solution goes here. So here is the solution, and we are just going to understand how this solution has been made, and this will be helping us to grasp the concept. Now what the mean value is, we have talked about. Let's say this is the x quantity that we are measuring. So these are x1 value, this is x2 value, this is x3 value, as we have talked about, and this finally is going to be x8 value. So mean value is defined as or written as by this expression. It is like x1 plus x2 plus x3 up to x8 divided by 8. So using that formula we are able to find this number. Now let's put these values in case you place all these values, and then this is going to be sum of these numbers divided by 8. After doing this calculation, you will find this as a answer because of this calculation. Then we know to represent this answer in the appropriate number of figures after rounding off, right? So after rounding off we are going to represent it as a 1.33. That means we are rounding off to this 2 has to be round off, so this is 7 is more than 5, so we will make it as a 3. For 2 places we are rounding it off. Point is, we can find the mean value if this kind of observations are known to us. Then it is asking about finding mean absolute error. So before we find the mean absolute error, we need to find the absolute error. So next thing that we need to do is finding out absolute errors in measurements. So in the first measurement, absolute error is written as delta x1. So delta x1 is going to be the mean value minus first observed value and the mod of it. Mean value that we have found out is a 1.33 and first observed value is a 1.29. So 1.33 minus 1.29, we are going to get the modulus value, that means positive value of it, which came out to be 0.04. The calculation you can do better. The point is how we are getting delta x1. This is absolute error in the first observation. Similarly, this is absolute error in the second observation. In the second observation, mean and the second observation, these values are equal. Hence, this is going to be 0.00. That means this is going to be 0. So absolute error in the second observation is 0. In the third observation, again we are writing it as a positive, even this x3 is more. So we are going to write the magnitude, that's a positive. Similarly, we will work for delta x4 and we'll keep on doing this up to delta x8. So these are basically the absolute errors in the measurement. So we find these absolute errors. Once we have found out this absolute error, now we can go to this and we can write about the mean absolute error. So mean absolute error delta xm, sometimes we also put a bar for mean purpose, or we can write delta xm. Now this is going to be delta x1 plus delta x2 plus delta x3 up to delta x8 divided by 8. Now this value is delta x1, which is 0.04 from here. Next value is from here, so that's a delta x2. Similarly, delta x3 and up to delta x8 they have been written. Divide by 8, so this came out to be this number. And then again we will be rounding off for 2 decimal places to make it 0.02, that's a round off. So by understanding the previous slide, you should be able to understand how this solution is going, how to find the mean value, how to find the absolute errors, then how to come to the mean absolute errors. So once you are able to find the mean absolute error and the mean value, then we can find out these two quantities, which is relative error and percentage error. So whenever this is asking for the relative error, so formula is here. So relative error is defined as mean absolute error divided by mean value. So I'm writing over here, or this you can treat as a formula. Relative error is defined as mean absolute error and mean value ratio. I will write them specifically in the next slide. Here we are just using the formula first. So, and we also write plus minus because errors can be positive as well as negative. So this mean absolute value came out to be 0.02, and mean value of this observation was 1.33. So we are putting them, dividing them together with each other. So when we are dividing these in this order, we will get this number. Again, we are going to round off to two places, we are going to get this. So that means this is the relative error in that experiment. And then lastly, you can be asked about the percentage error. Once we get the relative error, we just multiply this by 100, that becomes percentage error. So percentage error is basically relative error, which is this number, into 100. So this will become this, that means plus minus 1.5% error is in this measurement in terms of percentage error. So let's write specifically formula for relative and percentage error in the next slide. But in this particular example, you should be able to understand how to get the mean value, how to get the absolute error in each observations, and how to get the mean absolute error. If you are able to find this, you might get one question in the examination based on this mean value or absolute error value or mean absolute error value. Okay, now let's go to the next slide and talk about relative error and percentage error in terms of their formulas. So relative error and percentage error. So for relative error, the formula goes like this: relative error. This is also known as fractional error. Sometimes we will call it as a fractional error. And this is defined as equal to mean absolute error, mean absolute error divided by mean value, mean value. So whenever we need to find this relative error or fractional error, we need to simply use this relation which says relative error or fractional error is mean absolute error divided by mean value of that experiment. In the previous example, you have just understood, you have seen this use of this. So we will be finding out the mean absolute error, and then we will finding out the mean value in these observations. We will divide, then this will come out to be fractional error or relative error, right? And then we can also write the formula for percentage error. So if it is asking for percentage error, so percentage error is defined as, again, this same formula, that means mean absolute error, mean absolute error divided by mean observation or mean value or true value, we can call it as a, into 100. If we multiply this by 100, then it becomes the percentage error. So we can find out what the percentage error is, we can find out what the this fractional error is or relative error is. So so far you have understood what is a absolute error, what is a mean absolute error, what is a relative error or fractional error, what is a percentage error, and the previous example was illustrating all of these values. Once we have understood what are the different type of errors, then now we can talk about how these errors are propagated during the calculation. Since one observation has error in it, then if we use this observed value in further calculation, then this error is going to move in that expression or in those calculations as well. So that's known as propagation of error, and there are certain rules for that. we can see that what are the rules and how we are going to use that. So let's go ahead. So let's talk about this propagation of error. Let's say we have measured a quantity called A, and so that's a measured value, and delta A is indicating the error in A. So this is the measured value of A, and delta is the error of A. So we say the value of that quantity is A plus minus delta A. So this is how we write the expression for measured values. We write a value, then plus minus some another value. So this is the measured value, we can say, and this is the error involved in that measurement, right? It will say that the value of measurement lies between A minus delta A to A plus delta A. That's what it says. So the value of that physical quantity which is being measured is between A minus delta A to A plus delta A. Here we call this delta A as error and A as a measured value. Making sense? So let's say A physical quantity has been measured and it is being expressed as A plus minus delta A. So A is the measured value, delta A is the error in that value. Similarly, we have another physical quantity that has been measured, and that is B, and it is written as B plus minus delta B. Then we are going to read it as B is the value or the magnitude of that particular quantity, and delta B is the error involved in it, right? So A and B, these are the two physical quantities which has been measured by different experiments. Now if these quantities are going to or they are undergoing some operations, then these errors are also going to be involved in those operations. Now how these errors are going to play their role in these operations, mathematical operations, thus we are going to discuss in this particular segment. And after the operation that we are going to put on this A and B physical quantities, the resultant quantity will also have some error involved because these base quantities are having errors in them. So this error is going to propagate or move from these basic quantities to that resultant quantity. So that's called as the propagation of error. So let's see how the error propagates. Now when we talk about the operations of mathematical operations, so basic algebraic operations are addition, subtractions, division, multiplication and power. So we are going to see how it behaves in different operations. Let's talk about the first, in addition or in some cases, or summation. So when we are going to do summation or we are going to sum these quantities, so let's say x is defined as a plus b. So we will be writing the value of a over here, we will be writing the value of b over here, that will give the value of x. And that's over for getting the value of x. But our focus is what is the error involved in x as well, because this quantity has to be written as x plus minus delta x. So what this delta x is, that's our concern. So delta x is going to be written as delta a plus delta b. It's as simple as anything, right? So if we are doing operation called addition or summation, then let's say x value is defining this a plus b, then what the delta x is going to be, it's going to be delta a plus delta b. Hence we can write this additional value or summational value as x plus minus delta x. So this will be the answer for sum of these two quantities which had error in them. So x value will be simply a plus b. In this operation we will not bothering about what is delta a and delta b. Then we need to find what the delta x is. For that sake we will be writing delta a and delta b. We will be adding them up to get this answer. So that's the sum. Second operation that's obviously going to be there is called difference or subtraction. So what we do in case of difference or subtraction? So let's say again x is indicating in this case as a minus b. So we are subtracting these quantities a and b, we are going to subtract it, so that's going to be the value of x. then what is going to be the value of delta x? Now, for delta x, we are going to write as a delta A plus delta B. Now, here you need to be a bit careful. We are not writing it as a delta A minus delta B, rather we are writing as a delta A plus delta B. Why we are writing this plus sign even though the quantities are being subtracted? The reason is this is basically trying to say the error in the value of x, and we know this the error in the value of x is going to be due to error in value of a and error in value of b. Now when there are two errors, errors are always being added up. Errors cannot compensate for each other. So if one quantity has error, another quantity has error, then addition is going to have further error. Subtraction is also going to have a further error because there is a plus minus, right? So and whenever we write the error, we write the maximum possible error. So this delta x is going to be written as delta A plus delta B. That means this is the maximum error that can be in the measurement of x. Okay, and we should not write minus over here. Hence we will be writing again final expression as x plus minus delta x, and in both the cases of addition and subtraction you'll find delta x will be same. It will be delta A plus delta B in both the cases. Then if we are going for multiplication and division, then what happens? So let's talk about the multiplication case. So if we are multiplying these numbers or these quantities together and then finding out x, so x will be equal to a into b. We will be taking this value of a, we will be taking this value of b, we will be putting here and multiplying together to get the value of x. So finding x is not difficult in either of the operations. Our focus is how to find delta x, that means error in x. Now here what the error in x is has to be written. We are not going to write this delta x is equal to delta a into delta b. No, we will not write in this manner. Okay, that means when the two quantities are being multiplied, errors are not multiplying, right? So what happens to them, we will be talking about over here. Now there is a rule, mathematical rule that we follow, and here I am writing in a short way. There will be this kind of stuff like delta x upon x is going to be equal to delta a upon a plus delta b upon b. This is going to be relation that we are going to use to find out what the delta x is going to be. So in order to find delta x, we will be using the x which is ab, we will be using the delta a which is there, we will be using a, then delta b, then b, we will putting the plus sign in between, and after solving this we will get this value of delta x. Okay, and hence finally we will be writing the expression of x as x plus minus delta x. In case of multiplication we are going to use this. That means we can say in case of summation and difference we use or we add absolute errors together to find out the final error. Whereas in case of multiplication we are not adding the absolute errors, rather we are adding the fractional or relative errors to get the relative error in the multiplication quantity. Exactly similar follows for the division. So in case of division, let's say the quantity is x, which is being defined as a by b. So a by b will be used for getting the value of x. Then to get the value of delta x, we will be using the exactly same expression. That means delta x by x is equal to delta a by a plus delta b by b. Right? Hence we will be writing this x as this quantity as x plus minus delta x. So that's the delta. Making sense? So in division we will be having again the same rule, that means relative or fractional errors has to be added up to get the fractional error in the division quantity. Again here we are going to use the plus sign, not the minus sign. So they two will have the same expression for error. division and multiplication, and they will be having same error in summation and difference. Here we are adding the absolute errors, here we are adding the relative errors. That has to be kept in mind. And the third case would be when we are having the next case would be when we are having the power expression or operation. So let's call it the fifth, power. Now let's say in this power x is given to us as let's say a raised to power m, b raised to power n, and this operation we need to do. So we will be finding out the value of a raised to power m, then b raised to power n, then putting here to find the value of x. Again, purpose is to find out what the delta x is going to be. So for that case or that thing, we will be using this expression. So absolute this relative error in x is going to be equal to m times delta a by a. That means m times the relative error in a plus n times the relative error in b. This is going to be used for the power expression. So if you remember this power expression, then you can deduce from it all these expressions like multiplication you can deduce division, you can deduce the power. Now this m and n can be any number, they can be positive, they can be negative, that means b can be in denominator, a can be in denominator, whatever it be, whatever the m is, you just write m over here, what is n is, you just write n over here, put the plus sign in between, write the delta a by a, delta b by b, then you can represent your answer as x plus minus delta x. So this is for power expression, this is for division expression, this is for multiplication, this is for subtraction, this is for summation. This is how the errors propagate. So if delta a, delta b is known to us, we can find delta x for all these operations, mathematical operations. In general, in calculations, we use addition, subtraction, multiplication, division, or power. Alright, so this has to be understood. I am hopeful that the first two you will be comfortable in the very first part. In the second part, that the crux point is to remember or to keep attention is this that we are writing the plus in between. Multiplication, divisions might be bothering a bit to you, how we are getting to this expression, how we are getting to this expression, how we are getting to this expression. If you want to know, I can explain shortly. This is coming by using logarithm function and differentiation operations. Differentiation you are going to learn in the next chapter, so then it will become easy, and you are also going to learn it in mathematics. So later on it will become very easy. For the time being, either you can remember this this we use for multiplication, this expression we use for division, this expression we use for power function. But still, in short, I'm going to explain how these are coming. If you can grasp that, that's good enough. Otherwise, we will be discussing them in detail in future. So let's give a brief description of that. So let's say we are talking about this operation called this multiplication. Take this multiplication first, then rest of the two will be following. Before we go for this, there is a symbol. This is called change. So when we write delta x, that's called change in x. Change in x. Here we are reading this change as an error. So we can also call this as error in x. So basically change and error, they are very close to each other, but they are not exactly the same. But yes, we can say change and error. Here we can use them in exchange manner. So delta x is talking about the change in x, which is also going to be read for us as a error in x. Now this is for x. Now there is a function called logarithm function. Logarithm function is written as log x. Now there are two types of logs. If we write here 10 or nothing, so that's called base 10, and another is log x with base e. E is a number, so exponential number, so that's called log base e. And this log base e in short is written as ln, simply ln x. So if we write ln x, that means it is reading as log x base e. Now if we apply this operation in this logarithm function, that means uh, change in ln x, change in ln x is basically equal to change in x divided by x. So this is you can think of a particular formula that you need to keep in mind, or you need to learn as of now. Later on you will be proving in mathematics how this delta ln x becomes delta x by x. Now this is true only if delta is very small, that means change is small, because our errors are very small and we are considering the change to be small. So when the change is very small, small change is equal to error. So when the change is small, we can always write like this. Okay. Now if we can use this expression, then we will be able to justify how we can find the delta x from here. Now let's come to this, and we are trying to understand how we can find the delta x out of it. Now to find the delta x, we will be first applying the logarithm function in both the side. So if we take log both side, so we are writing log base e, that is ln. So it becomes ln x on the left hand side, and right hand side it will be ln a into b. Ln is basically log. Now log has so many properties you will be learning, or either you have learned, you might have learned. So if it is written as ln a into b, which can be written as separately ln a plus ln b. So from here we can get ln x is equal to ln a plus ln b. So we are using or applying this logarithm function in both the side, then writing in this manner. Now what we are going to do in the next step, we are going to apply the change in both the side. So we apply change, that means ln x, change in ln x is equal to change in ln a. Change is a operation that can be distributed over the summation, so it will go to both the functions, and it can be written as ln b. Now you can use this this result that I have put in placed in this box. Ln x change is delta x upon x. So this left hand side will become delta x upon x is equal to, this will become delta a upon a, plus this will become delta b upon b. Now if you see it carefully, it is the same expression that I have written earlier to find the change in x or error in x. Now this is called a fractional or relative error in x is going to be equal to relative error in a plus relative error in b. This is coming because of this mathematics. Now as we did for this addition, this multiplication case, can we find similarly for the division case? So if you divide it, you will find a minus sign coming over here. Now this minus sign will be there, then this minus sign will be there, but we will again claim that when we call it as an error can never be subtracted. Error is always being added up. So we will be removing this minus sign to make it plus. So for division also it will become the same expression. Quickly we can also check for the power expression, and you will be able to understand how it comes to that relation for power case. Let's say it is a raised to power m, b raised to power n. Then next step will be taking the logarithm function both sides. So it becomes ln x is equal to ln a raised to power m, b raised to power n. Then you can say they can be separated. So it becomes ln a raised to power n plus ln b raised to power m, and this was m. So whatever it is, we will maintain that. Then there is also expression rule of logarithm function that this power comes in front. So this will become m times ln a, and this becomes n times ln b, and this is ln x. Now next operation will be to placing this change in both the side or error in both the side. So if you are placing this error, so this error is going to be, this is change in ln x is equal to, m is a constant, m is not changing, then change in ln a, then n is not changing, so this will be change in ln b. Then this will ultimately will become delta x upon x is equal to m times delta A upon A. We are using the rule that we have listed over here, this rule, plus n times delta B by B. This was the expression we wrote for power expression. So whenever there is a power, then error goes like this, right? If you have understood this, then it's okay. That means you have understood how to write these expressions. Otherwise, you can remember this is for multiplication and division, this is for power, and these quantities will be given to you. You can easily find out what the delta x is. That means we will be able to find how the error propagate in these kind of operations. Making sense? Well, based on this learning, there's a question that you need to answer. This question says two resistance R1. R1 is written as a 2.2 plus minus 0.1 ohm. That means you can understand the value of R1 is 2.2 and the error in that is zero point 0.1. Similarly, R2 is known to us. They are connected in series. We need to find the resistance, equivalent resistance of this combination. And you might be knowing the resistance when they are in the series. So equivalent is written as R1 plus R2. Then you need to find R1 plus R2. When you do R1 plus R2, that means 2.2 plus 8.0, it will become 10.2. So you will get 10.2 in all the options coming. Then plus minus rest this expression is coming because of error. Then you need to measure the error, what this delta RS is going to be, and then you will get your answer out of these four options. So solve, and then after solving, get your answer. Then comment the answer in the comment section, and if all of you are going to get the same answer, that's going to be most likely correct. Or in other terms, I can say you will be able to find out these the correct answer if you have understood all the aspects that we have dealt in this particular video. Once more, I'm going to say, if you are not able to understand this mathematics of logarithm and change, it's okay. You simply remember how we write this error when this multiplication, division or powers come in, and similarly for addition and subtraction. Over the time, when you will be able to understand the mathematics, it will become very simple. Okay, so this is all in this video, and in the next video we will be having examples and questions that are important and which normally uses this error and measurement analysis. So that will be the last video for this particular chapter. With that video, this chapter will be completed. So in this lecture, whatever you have been stated, make your proper notes and revise and grasp. If you are not able to find proper meaning, then you just ask in the comment section or otherwise. Okay, so that's all. Thank you everyone. Have a good time.